Okay, in this video, we're going to discuss the final form of a quadratic relation, which is known as factored form. So in our previous lessons, we've looked at standard form of a parabola, ax squared plus bx plus c. And an example of that one, let's just look at a very quick example. So my parameters are a, b, and c. The a value tells me the direction of opening. So because a is bigger than 0 or positive, this parabola opens up. And the c value tells me my y-intercept. So it crosses y-axis, 0, -8. Then we looked at vertex form, a x minus h squared plus k. So let's look at one quick example there. Let's say I've got an a value of -2, x plus 3 squared minus 4. So again, the a value, we use the same letter in vertex form. For the a, it represents the same thing. The a value is negative, the parabola opens down. Vertex form is called that because we're able to read off the vertex. So the vertex is hk. Remember to flip the sign of the number in the bracket. So my vertex is going to be -3, -4. So h is the x coordinate and k is the y coordinate of my vertex. So those are the two forms of quadratic equations that we've discussed so far. What we're going to look at today is the third form, which we call factored form. A equals, and then in brackets, x minus r, and in our second pair of brackets, x minus s. So the first thing to notice is that, again, I'm connecting or linking x and y. So these parameters now a, r, and s are going to determine the shape of the parabola. A, you notice, is always the same in all three of these forms because a is always telling us the same information. Does this parabola open up or down? The other two parameters, I'm using different letters. They're just arbitrary letters that we've chosen because they're going to represent different information. And in this case, r and s are going to tell us the zeros of the parabola. So let's look at an example. Maybe zoom out so we can see the entire parabola. Again, the a value is +2, so the parabola opens up like a smile. And my two zeros, or my two x-intercepts, are r and s. And again, the -r and the -s reminds us to flip the signs. So I've got one x-intercept at +2, 0. And I have my other x-intercept at -6, 0. So from factored form, which I can identify by the two sets of brackets, I can find the zeros of my parabola. Let's look at another example. So for example, y equals 1/2. I'm going to get rid of my line so we can discuss it first. X plus 2, x plus 8. So if I see an equation in this form, the first thing I want to do is we want to identify, well, which form of the equation is it? If I've got two sets of brackets, it must be what's called factored form. And if it's in factored form, I know the following information. First of all, my a value is positive, so the parabola is going to open up. And then again, I know my two zeros. It's the two numbers in the brackets, but I need to flip the sign. So I should have my x-intercepts, another term for 0, at -2, 0, and at -8, 0. So when I draw this parabola, I should see it opening up and going through those two x-intercepts. So that's kind of our introduction to factored form. And if we move over to my desk, let's just take a look at what information we can learn from a parabola that's given to us in factored form. So sometimes it helps if we immediately write down the parameters. So remember that factored form, I was trying to switch colors, but I had the wrong cap. So that's okay. We'll just do this all in black. X minus r, x minus s. So in this example, I have an a value of -2. I have an r value of +2 and an s value of -6. Remember, the fact that it's x minus r minus s means I just need to flip these signs. -2 is +2, and so on. So first of all, the a value is negative, so we know that this parabola is going to open down. And the r and s values are giving us our two x-intercepts. So I know that our x-intercepts are going to be 2, 0, and -6, 0. Okay, so that's a helpful starting point. What else can we find out if I know this information? Well, I know that every parabola is symmetric. So if I know the two zeros, the line through the middle of the parabola, the AOS, is going to be directly in between those points. So to find the point directly in between, I could either count on a graph, but I could also just find the average. So what I mean by that is I could add these together and divide by 2. So my AOS is going to be 2 plus -6 divided by 2. So I have -4 divided by 2. So my AOS is at -2. I'll show you on a sketch how this works. So again, a sketch means I don't need to use graph paper. It doesn't need to be to scale. But I'm going to kind of show you the main ideas and the key information. So first of all, we know this parabola opens down. It has two x-intercepts at, let's say, -6, 0, and at +2, 0. And what we've been doing here to find the AOS is we're trying to find that vertical line through the middle of the parabola is exactly halfway in between those 2 points. So halfway between -6 and 2 is going to be -2. So I'll just draw that dashed line, which has the equation of x equals -2. And we also know, because our a value is negative, that our parabola opens down. It's going to look something like this. The two things we don't know is we don't know our vertex, our point at the top, and we don't know our y-intercept. But remember that these equations are kind of like input-output machines. If I know a value for x, I can easily find the value for y. So why don't we use that knowledge to solve for the vertex and the y-intercept? So first, the vertex is the highest point. It's always in the middle of the parabola. So it's always on the AOS. So I know the x-coordinate of the vertex is -2 because it's on this vertical line going through -2. And I just need to solve for the y value, the y coordinate. So I'm going to sub in the AOS into my equation to solve for the y coordinate. So we can write down what we're going to do to solve for the y coordinate. So I'm going to rewrite my initial equation, but wherever I used to see x, I'm going to replace it with the x value at the vertex, which we know is -2. So I'll have -2 minus 2, and I'll have -2 plus 6. And now I can just evaluate, remembering to follow BEDMAS. So I'm going to do what's in the brackets first. -2 take away 2 is -4. -2 plus 6 is +4. Now I'm multiplying three numbers together. -2 times -4 is +8. 8 times 4 is 32. So the y coordinate of my vertex is 32. And my vertex is going to be at this point -2, 32. So of course my sketch isn't to scale. But now I've found the vertex. So as long as I know the axis of symmetry, I can sub that in to find the vertex. The other point that we'd like to add to a lot of our sketches is the y-intercept. Y-intercept is where we cross the y-axis. That's the one point in the graph where there's no horizontal distance. In other words, my x-coordinate is 0. So to find that y-intercept, I know it's going to be 0 something. So I can sub in x equals 0 to find the y-intercept. So again, I'm going to take my original equation, and every time I see x, I'm going to replace it with 0 because that is the x value at the y-intercept. And again, when I have numbers in a row separated by brackets, it means multiply. -2 times -2 is 4. 4 times 6 is 24. So my y-intercept must be at 0, 24. So again, my sketch isn't to scale. It's not perfect. I think it would be a lot of a kind of a taller and skinnier parabola. But the idea is, when I have an equation in factored form, I can really quickly read off the zeros, read off the direction of opening. And then with a little bit of work, helped along by a sketch, I can calculate the AOS, the vertex, and the y-intercept. So I've got this beautiful sketch that is all the key information about my parabola. The only other type of question that we're going to do on this video is kind of work backwards. Let me get a fresh piece of paper. So if I'm given information about the parabola, I can also determine that equation in factored form. So let's say we know our two zeros are at 4, 0, and 10, 0. And we also know that the parabola goes through the point, let's say 3, 5. And what we're going to do is try to determine the equation in factored form. So as always, when we're trying to determine an equation, we want to start with our target. We want to find this equation in factored form. In other words, we need to find parameters a, r, and s. Well, if I know the two zeros, those are r and s right away. And again, anytime information is moving in or out of the brackets, we're going to flip the sign. It's x subtract r. We have x minus 4 and x minus 10. Okay. And again, just like when we were determining the equation in vertex form, I've got to solve for a. As long as I know one other point in the parabola, I can plug in those coordinates for x and y and then solve. There's only going to be one parabola that has these zeros and goes through that other point. So I'm going to plug in 5 for y, and I'm going to plug in 3 for x. And now we're going to be able to solve for our a value. And again, we're going to always do our brackets first. And then I'm multiplying a by -1 by -7. -1 times -7 is just 7. So 5 equals 7 times a. So a equals 5/7. And now I can write the equation of my parabola in factored form. I know a, and I also know my other parameters, r and s. So when we know the vertex of a parabola at another point, we can find the equation in vertex form. We've done today, if I know the zeros in my other point, then I can find the equation in factored form. I think sometimes it would make more sense to use the term factored form. We could also call this zero form because it allows us to use or to determine the zeros. Again, Desmos is a fantastic tool for checking answers in this course. The information that we were given is that we had two zeros, two x-intercepts at 4 and 10. And then we knew that it also went through some other point 3, 5. So this was the equation that we were trying to find, the parabolas that go through these 3 points. And algebraically, this is what we came up with. We had x minus 4, x minus 10. And sure enough, it's got those two x-intercepts at 4 and 10, and it goes through that extra point. So that's kind of a quick recap of our lesson on factored form. Thanks for watching, and let me know if you have any questions.